when you are working through the half angle identities that we're going to start with, you're going to have to, first of all, be able to select the identity that you're going to be using, and that's pretty easy to find. I'll show you that in just a moment. But then once you get there, then it's kind of mathy. You're going to go back into some geometry, doing some SOHCAHTOA stuff, right angle trig, or right triangle trig, and working with some fractions. So there's kind of a lot to think about when you go through them, but once you get the hang of it, it's not so bad. So these are the half angle identities that we're going to be using. I squiggled underneath these because if given the option of which identity to use when it comes to tangent, I lean towards the ones that don't have the radical in it. I don't have that luxury for sine and cosine, but I do for tangent. So I'll lean towards the one that has the ones without the radical in them. Okay, so let's kind of jump in and see how this goes. So first of all, like I said, you've got to choose your identity, and that comes from right here. What are you looking for? So I'm going to pick one of the tangent, in this case theta over 2 identities, and one of them I believe is 1 minus the cosine alpha. We're going to be using theta over sine theta, and I just want to double check and make sure that I did pick a right one. Yep, so I chose this guy right here. You can use any of them. I just chose that one. That's the one I remembered. So when I'm choosing that, I just have to sort of fill in these values. They give me that the cosine is 3/5, so I can do 1 minus 3/5. The problem is I don't know what the sine is, and I need the sine to finish off this equation. And so this is where my right triangle geometry comes into play. I'm going to draw that picture and do some Pythagorean theorem. Cosine is the adjacent over the hypotenuse. I have to figure out the opposite side. So 3 squared plus something squared is 5 squared. And I just work my way through that. So it turns out that that missing side is 4. And sine is opposite over the hypotenuse. I'm just doing SOHCAHTOA, opposite over hypotenuse. So the sine is 4/5. I do have to consider where I am, and this right here between 0 and pi over 2 is in the first quadrant. That means both the cosine and the sine are positive. And I do have to consider that because if I were in a quadrant which would make the sine negative, I'd have to make sure I put a negative on that. But I'm not there. So, oops, I wrote 3/5 and I know it's 4/5. So I'm going to put that over 4/5, and now I'm going to do the math. I get 2/5 over 4/5, and when I simplify that down, I end up with 1/2. There's my final answer. So it's picking the right identity and then doing the math to plug it in. So I'll go on to the next one. I have the sine half angle. So that's plus or minus the square root of 1 minus cosine theta over 2. I need the cosine theta to figure this one out. They give me the tangent, so I'm going to draw that right triangle again. Here I am, theta. The tangent is the opposite over the adjacent, so 4 and 3. Well, we did a triangle like this before that had 3/4, so if this missing side is 5. Again, if you can't tell, do the Pythagorean theorem. 3 squared plus 4 squared equals the missing side squared, and it turns out to be 5. We're going to see 3, 4, 5 right triangles a lot. Okay, so I need the cosine here to figure out this formula, and so the cosine of theta on this triangle is the adjacent over the hypotenuse. But here, between 3 pi and 7 pi over 2, that's in the third quadrant, which is negative, negative. So it's between 3, so 1, 2, 3, and 3.5. That's in the third quadrant. That's where I am. That's negative, negative, so the cosine is negative. So when I plug it in here, I have plus or minus the square root of 1 minus negative 3/5 over 2, which is plus or minus the square root of 8/5 over 2. That's plus or minus the square root 2 over 1. So I'm going to simplify. I can multiply by 1/2, multiply by 1/2. That cancels out the denominator. That leaves me with 4/5. I can do the square root of the top, which is 2, and the square root of the bottom, square root of 5. And then I have to, oops, sorry, that's plus or minus is what I meant to write there. Plus or minus. And then I have to rationalize my denominator. So I have plus or minus 2 times the square root of 5 over 5. Now, the final thing that I have to do, and this is why I don't like to use the ones with the radicals on them, if at all possible, because I have to figure out what is it, plus or minus. Well, that comes from this original thing as well. I'm starting in the third quadrant, so 3 pi is less than or equal to theta, which is less than 7 pi over 2. But I'm looking for the half angle here, theta over 2, so I have to cut that in half. Well, I can't just cut that in half and not do the rest of it, so I'll cut the 3 pi in half, and I'll cut the 7 pi over 2 in half. And that puts me between 3 pi over 2 and 7 pi over 4. So think about that. That's 3 pi over 2 is right there, and 7 pi over 4, 1 3/4. So I'm in the fourth quadrant. And in the fourth quadrant, I have positive cosines and negative sines. I am interested in the sign here, so I am interested in the negative answer. So my final answer is negative 2 times the square root of 5 over 5. So you can see how that is, like I have a lot to think about when I do these. Figure out the identity, figure out any missing parts, do your math, and then especially if you have one of these guys, you're going to have to actually figure out the final sign. So I've got another one of those where I'm doing the cosine half angle, and that one's plus or minus the square root of 1 plus the cosine of theta all over 2. Again, I'm given the tangent. This is in the fourth quadrant. In the fourth quadrant, that is positive cosines, negative sines. So when I draw my triangle, oops, I'm not going to draw that like that. So when I draw my triangle, I'll label the opposite 12 and the adjacent 5. And it's 5 squared plus 12 squared equals something squared. I have to find that missing side. 25 plus 144. So that's 169. Square root of both sides, 13 is x. So this missing side is 13. I'm interested in the cosine of the angle. The cosine of theta is the adjacent over the hypotenuse. In the fourth quadrant, the cosine is positive. So when I plug this into this equation, it's 1 plus 5/12. Sorry, 5/13. That should be 5/13 over 2. So plus or minus 18/13 over 2. I'll simplify. That gives me plus or minus 9/13. Square root of 9/13. Square root of 9 is 3. And then I have to rationalize the denominator. 3 times the square root of 13 over 13. Last thing I have to do is pick that sign. Again, I go from the original, but I cut it in half. So originally 3 pi over 2 is less than or equal to theta, which is less than 2 pi. But I'm interested in theta over 2, so I'll cut everything in half. And so 3 pi over 4, between 3 pi over 4 and pi, that's in the second quadrant. And in the second quadrant, the cosine is negative. So again, that means I'm only interested in the negative answer. So negative 3 times the square root of 13, negative 3 times the square root of 13 over 13 is what I meant. And this one is the tangent one again. Again, I like it that I don't have to do this end part where I had to think about what the end sign is, because I can choose one of those other formulas. I'm going to use 1 minus cosine theta over sine theta again. That's the one I remembered. That's the one I'm going to use. I already have the cosine, so 1 minus 4/5. I need the sine. I'll draw my triangle. Cosine is adjacent over hypotenuse. I've seen this triangle before, so I could fill in that missing side. Like I said, I need the sine of this, and the sine is the opposite over the hypotenuse. But where am I? That's between 3.5, so 1, 2, 3.5, and 4, so I'm in the fourth quadrant, and that is a negative sign location, so over -3/5. And then I go ahead and simplify. I get 1/5 over -3/5, and I'm down to -1/3. So again, it's really just kind of being aware, looking at the identities, choosing the one that you're going to use, going back in time into your geometry days, and doing some of that SOHCAHTOA stuff, figuring out your missing sides, and then simplifying. Remember, I'm just manipulating, I'm moving things around, I'm trying to find the value, and I'm doing so by using an identity. So the first thing that I have to do is figure out which identity I want to use. And I'm going to be using the sine half angle identity, and that came from what it said, find the sine of theta over 2. So I chose the sine half angle identity. That went back to my first page, the sine half angle identity. It says alpha in here, but the equation, or what we're solving for, is theta. That's just a variable, and that can change all the time, so I'm using theta in the formula. Remember, I need to use the cosine of theta in order to find this, but they gave me the tangent of theta, so I'm going to draw a right triangle and label tangent is the opposite over the adjacent. Remember, don't worry about that negative there. That negative is there because theta is, we were told, theta is in the fourth quadrant, and tangent in the fourth quadrant is negative. So it's not like I want to say the 4 is negative or the 3 is negative. I just know that the tangent itself is negative. When we're labeling our triangle, those are just measurements of sides, and the measurements are always going to be positive distances or lengths. So this should look familiar, a 3, 4, 5. We've seen those a lot. We are going to get into some that maybe aren't as obvious. If you took a picture of the Pythagorean triples in class, you can pull that out on your phone and take a look at it, because we'll get into some other kinds, and we might even get into some where we're actually going to have to do the Pythagorean theorem. It's not actually a triple up there. So anyways, I'm here, and I'm going to use this triangle to find the cosine. And so the cosine of theta on this picture is 3/5. Because I'm in the fourth quadrant, the cosine is positive, so my 3/5 is positive. So when I use this identity, it's plus minus 1 minus 3/5 over 2, and I just have to go ahead and do the math. On your assignment, some of them came out with some heftier values, and that's going to happen. And again, we're going to see some of those as we work through today. It's not always going to come out super nice looking. Even when we were doing them last time, we had some that had radicals left in them, and that's normal. Okay, just do the math and obviously do it correctly. So this is 1 or 5/5 minus 3/5. 5/5 minus 3/5 is 2/5 over 2. Put that as 2 over 1, multiply by 1/2, multiply by 1/2 on the top and on the bottom. Remember, that's multiplying by the same thing. Multiplying by 1 doesn't change the value, just the look, and so that gets rid of that denominator. So I'm left with plus or minus the square root of 2's cancel out, 1 over 5, which is the square root of 1, or 1 over the square root of 5, plus or minus. Rationalize my denominator. I have plus or minus the square root of 5 over 5. Now I need to figure out if it's positive or negative, and so this is always my last step, and I only have to do this step if I use one of these identities that has a radical in it and a plus minus in front. If I don't use that, and you're going to see in the double angles, none of them have that, so we don't have to do that final step. The sign will work its way out. I do have to work through it up here, making sure. That's why they tell me where I am. That's why they tell me where I'm looking at, because then I can figure out what the sign of my trig function is. Right here, I need to do that final step because I am cutting the angle in half, and I'm going to land somewhere I don't know. I need to decide whether it's positive or negative. So I'll take that 3 pi over 2 less than or equal to theta less than 2 pi, and I'll cut everything in half. That gives me 3 pi over 4 is less than or equal to theta over 2, which is less than or equal to pi. And that looks like that is in the second quadrant, and second quadrant is negative, positive. I was trying to find the sign. That came from here. Find the sign. The sign is positive in the second quadrant, and therefore I only care about the positive answer. My answer is square root of 5 over 5.